Extreme weather events, they're the most damaging of climate change impacts, inevitable climate change impacts to human populations, but also to their crops.
Well, hello, everyone. Welcome to today's Climate Emergency Forum. Our discussion today, extreme weather disasters. Well, as you know, with the warming of the global surface temperature, as well as the oceans, the atmosphere, we'll see more and more extreme weather events. So Paul and Peter will be speaking to the science of that. And I'll be looking at all of this from a more sociological perspective. That is, how will this actually affect us as humans? And what can we expect? How do we prepare ourselves? If we're going to see more of these extreme events, well, we have to know something about what we can expect and what we can do. So I want to talk to you about a recent report that came out, published by the National Intelligence Council here in the United States. And they spoke to some of the greatest challenges that we'll be facing in the near future. And one of them, of course, is a warming world. A warming world, and not just the warmth, not just the heat, not just the increase of that. I know that that's what we're always speaking to, but the fact that the Earth is warming has consequences. So I want to just emphasize that the past 10 years have been the hottest on record, and every decade since the 1960s has been hotter than the previous one, every single decade. By the way, 2020 tied for the hottest year on record ever. So all of the extreme events that we have seen, most recently, Hurricane Harvey in Houston, the hurricane that hit Honduras. We all remember Hurricane Katrina. We'll be seeing more and more of those. So how will that affect us? Well, as it happens, quite a lot. And it's not just those weather events, but it's also everything that's happening with us in the world. We all know that the infrastructures in our modern cities are falling apart. We know that the President of the United States, President Biden, has an infrastructure bill going into for discussion, and there's already been problems about it. So I want to speak to you about how this will affect us, this current fragmentation that we're seeing due to social media, people breaking up into silos and fracturing relationships, not just within families, but cities and states. The challenges that states and cities are facing regarding the needs of the people and their inability to meet those needs, as well as increased competition between individuals and countries. Who's going to be on top? Who's going to win? Well, you know, as it has been, it seems as though it will be. Those who have been affected by climate change the most will continue to be. I want to speak to the issue of Hurricane Katrina. What happened there? Well, we all know that it was an absolute disaster, but let's not make the mistake that assuming that it was a natural disaster. Yes, we said that it was the big one. And for those in New Orleans, that means a Category 5. But I'd like to remind everyone out there that it hit the city as a Category 3. Well, what really happened that devastated the city of New Orleans? It was the levees. The levees built by the Army Corps of Engineers was not able to withstand the force of a Category 3 hurricane. So the entire city flooded, and we know what happened to the lower Ninth Ward. So in terms of poverty, those who were in the poorest parts of the city were affected the most. And when people who have little to no resources are moved from a place where they have all of their connections to an entirely different place, in another state in the country, well, they have even less resources then. We're adding to the toll then of human suffering through our seeming slow pace of keeping up with our infrastructural needs and our inability to address these people living on the coasts and having them move more inland, which is going to have to happen. And to speak to the science of this, I'd like to turn to Paul. Paul, can you speak to the science of why these extreme weather events are happening more and more?
Yes, thank you, Regina. Last video, we discussed heat waves, which is just one example of extreme weather events. So extreme weather events are increasing significantly globally in terms of their frequency of occurrence, their severity or intensity, their duration, so how long they're lasting, and they're also occurring in new locations where they did not occur before. And the main reason for this ramping up of extreme weather events or changing of the statistics of weather is the incredible warming in the Arctic. So the Arctic is losing, of course, sea ice and snow cover at very, very rapid rates. So this lowers the temperature difference. The Arctic exhibits tremendous warming, and therefore, relative to lower latitudes, the temperature gradient or the temperature difference is much lower. And what this does is this slows down the jet streams and they become wavier in the north-south direction. So we have very, very strong ridges in the wave, if you like, that go to the far north. And we have very, very low, very, very deep troughed depressions, or like the trough of a wave, that go very, very far south. And that carries, because the jet stream acts as a border, if you like, between the cold, dry Arctic air and the warmer, more humid southerly air, it acts like a wall, then that cold air surges southward from the Arctic into the troughs, and the warm, humid air surges northward into the ridges of the jet stream. So this happened, as we discussed last week with the European heat waves. It went from a very powerful ridge of extremely warm air and tremendously warm heat in Europe for about a week. And then that shifted as the jet streams moved and shifted. It became very, very cold in Europe. And of course, this has a tremendous effect, negative effect on people's lives, on infrastructure, but also on plants, and animals, the ecosystems outside in our natural environment. For example, in the heat wave, the buds were all blooming. And then, that killing cold spell a week later basically killed all of the buds. So huge economic damages to crops that are being grown. I think in the case of Europe, mostly the wine crops were affected. So, you can call this change from one extreme to the other stream, like I've called it in the past weather whiplashing or weather wilding or weather weirding. And it has huge effects on all infrastructure. For example, think of rail lines, okay? It goes from very, very hot to very, very cold to very, very hot. Think of roads. Think of any infrastructure, houses, anything else, right? The stresses on the infrastructure is enormous. So it's not just it affects everything basically, and it affects how we grow food. So meteorologists call the event when the jet stream is very strong and locked into place, blocking, or a term you may have heard was ridiculously resilient ridge, which was over the Pacific, causing tremendous warming and hot spots, marine heat waves off the California coast. Things like that, where we're getting these persistent jet stream blocking events, are having a tremendous impact. And, think about as we go to an Arctic without sea ice at the end of the melt season, and we're rapidly heading there. I mean, the sea ice did not form properly this past winter. So it's bumping along at near record lows, and the ice is very thin. And that exposes it to very, very rapid summer melt, which is likely to happen this year. So, as we continue to lose sea ice and snow cover in the Arctic, the Arctic will warm that much more. And the jet streams will become even more fractured and chaotic. And you know, their behavior will become more dependent on the contrast of temperature between the land and the ocean, and topography on the land. Things like that will dictate where the ridges and troughs lie, you know, as opposed to the temperature difference with latitude, which is decreasing more and more as the Arctic continues to warm. So extreme weather events are going to get much, much worse in the near term.
Thank you so much, Paul. I mean, one of the things I know that the jet stream is something that you're very interested in, and of course we all should be. What comes to mind, though, is this is such a complex notion. It seems like it's so important to concretize what this means, and because I think regular people, I include myself in that because I'm not, you know, schooled in the hard sciences. I'm more of a social science individual. When they see these events that have been exacerbated by something such as the jet stream, it's so easy to make other associations as to why they're occurring. And so thank you for bringing that up. And I really hope that we can continue to speak about the jet stream and make people really comfortable with what it is and what it means. And Peter, I'd like to hear what you have to say.
Yeah, we've already mentioned, and Paul's already repeated the very important fact that extreme heat waves predictably have always been known to increase with global surface warming. And like Paul said, both the frequency, the duration, the severity, and all that is accelerating. That's predictable. But actually, the other extreme weather events have also been predictable for a long, long time. Should add forest fires, of course, to the heat waves. Forest fires are regionally increasing, particularly in the west of the North American continent. And, you know, we're looking at unprecedented disasters, right? Disasters of a scale and severity that these regions have never, ever seen before. Unfortunately, people's memories seem to be rather short. No one is immune, no country, no region is immune from the increase in all these extreme weather events. Just consider 2017 Hurricane Harvey and the city of Houston. The city of Houston, this was absolutely unbelievable, right? So overnight, the extreme weather event of Hurricane Harvey dumped 9 trillion gallons of water on the city of Houston. No city had ever experienced anything like this before in North America. So these are records, and also Katrina, these are records that we really should remember and not forget about them. It amuses me that the media still calls these natural disasters, right? They're completely unnatural disasters. They're driven, and there's absolutely no question about that, from our continued emissions of greenhouse gases, particularly burning fossil fuels, particularly carbon dioxide. And these are not reversible, right? We're on this trend of all of these extreme weather events are increasing and some of them are accelerating, right? And we have extreme disasters, but we also have climate disruption as well. I mean, imagine this. March of this year, because we're in a La Nina, was globally somewhat cooler than last year, but Japan experienced a temperature increase of 3 degrees C. I mean, that's phenomenal, right? In March, Japan, 3 degrees C. And also massive heat affecting northern China, affecting southeast Russia, affecting the central continent of the United States. Extreme weather events, they're the most damaging of climate change impacts, inevitable climate change impacts to human populations, but also to their crops. So increased intolerable temperatures in the summertime hit crops, and crops collapse. Heat waves, of course, hit crops and crops collapse. Drought increases regionally. It's increasing regionally on these drought-prone regions, but it's also spreading up, of course, into the southwest, and the entire west of the United States is now gripped by an extreme drought situation. This was predicted by the models many years ago. So United States, right, the world's best food-producing cereal breadbasket producer in the world, is not immune from extreme weather events. People in the well-to-do, Europe perhaps, and Canada certainly, and United States, sort of, I think they got the impression that they're invulnerable to climate change and extreme weather events because they've been told for decades that these are going to hit hardest and first to the tropical regions. Well, they're hitting us hard, and they're hitting us very, very hard indeed. We're having unprecedented record extreme weather events right across the northern hemisphere. They are increasing. Just last year, in October or December of 2020, the United Nations reported that extreme weather events had doubled just since 2000. Just imagine that, just since 2000, that's no time at all. Globally, extreme weather events have doubled. And the report from the UN said that this was largely attributable to global climate change, global climate disruption. I don't believe that we're going to be able to stop extreme weather events with geoengineering. I don't believe that can possibly work. In many respects, I think it can make our extreme weather events worse, and it's certainly not going to help the oceans. So we already have extreme heat and extreme temperatures affecting the oceans. A paper just published, I think maybe a week ago, recorded, and all of these impacts that the scientists are recording, they're absolutely devastating, but it seems we're not actually devastated by the news, and we really need to be. So in the tropics, the fish are already beginning to disappear. This paper finds that at 20 degrees of sea surface temperature, the fish populations literally collapse. And this inevitably is going to get worse. And can you imagine the devastation? This is happening at 1 degree C. 2 degrees C, we all realize now it's too late to avoid that. 3 degrees C is what our governments are condemning us to. So the tropical regions, if we carry on allowing our leaders and governments to do what they're doing, will be devoid of fish. And we have millions and millions of people dependent on their local fisheries for their main source of protein. So the entire planet is being hit everywhere by extreme, disastrous impacts of global heating and global climate disruption. It can only get a lot worse. So we really do have to rise up, and we really do have to get very energetic and aggressive, like Extinction Rebellion, for example, because there's no question about it, our very survival is at stake. Antonio Guterres, the United Nations Secretary General, warned us about this year after year. So if we want to experience wherever we live and live in a planet where extreme disasters, catastrophic impacts are not common and not unprecedentedly severe, we have to stop emitting. We have to stop burning fossil fuels for energy. It's really rather simple.
Thank you so much, Peter. And thank you for mentioning Japan. And as we know, the archipelago of Japan is being threatened by sea level rise, and all small island nations and all states that are along the coast are also being threatened by sea level rise. And I also appreciate that you mentioned Hurricane Harvey, because it ties into what Paul was speaking to regarding the jet stream. Now, I have some friends in Houston, and they know that I am very interested in global climate change and global warming. And they insist that the reason Hurricane Harvey was so bad had nothing to do with climate change. They don't make that correlation that the rain stalled over Houston for so long because of the jet stream. And I think that's why it's so important for us to be able to make these connections for people, because these concepts they're difficult for anyone. So Paul, do you have anything to add to that?
Yes, thank you, Peter and Regina. So I mentioned the jet streams slowing down and becoming much wavier and stuck in place. Also, for every degree Celsius of warming, there's about 7% more water vapor in the air. And that, as that water vapor rises up and condenses and forms droplets, it releases, there's a huge, tremendous release of latent heat energy, which fuels the severity of these storms. Now, I mentioned that many places are getting torrential rains that are leading to flooding. And we used to associate torrential rains with living in the tropics. But, you know, at higher and higher latitudes, we're getting torrential rains, and these are not being carried very quickly across land surfaces. So they tend to linger in one place for longer, as you mentioned, stalled, or the storm almost seems to stop. And then you get tremendous amounts of rainfall in a very short period of time. So with Harvey in Texas, the jet streams were moving so slowly that Harvey actually went ashore in Texas. Half of the storm was still over the very, very warm ocean, which continued adding moisture and fuel and energy to the storm. And the other half was over land, which just dumped tremendous amounts of rainfall. And it was only moving about a mile an hour. So Harvey went up the coast of Texas, and it took about 4 or 5 days for Harvey to do that. And this is really strange and bizarre behavior for a hurricane. Normally they go ashore, they're moving at a decent clip, and they quickly dissipate over the land. There was also so much rain dumped on the land from Harvey that it was almost like, to the storm, it was still over ocean. You know, all of this groundwater on the surface acted almost like an artificial ocean, if you like. So for the storm dynamics, you know, that kept refueling and intensifying the storm. So yeah, I mean, this is all connected to climate change. If this type of thing happens, because the jet streams are so much more slow, you have much more regional, local factors influencing the duration and length of some of these storms. So, you know, we've had some massive snow dumps on the coastal areas of the eastern US, for example. And this is storms that are getting, it's like taking a fire hose from the ocean and dumping it on land. And if the temperature is below zero and it's in the winter, in the fall or the spring, most often it occurs in the fall, then you get enormous snow dumps along these coastal regions. So the jet streams are having much less influence regionally. You know, they have a huge influence globally on the overall system and the large scale system in the ridges and troughs. But in some region, on a regional or local scale, you can often get this disconnection between the ocean, warm ocean, and the cold land. And you can get tremendous dumps of either rain or snow in those particular locations. You know, and we're also seeing this in the far north. And, you know, there's been massive rainfall events in Norway along the coast with the same sort of situation. You know, very little influence. The jet streams are not dragging these storms away. These storms are lingering and persistent, and they're just staying in one spot causing tremendous, amounts of, record-breaking rainfall or snowfall, what be it. So extreme weather events are getting much, much worse. They're getting more frequent, they're getting more severe, and they're happening longer. And they're also happening in locations where they never happened before. We're getting weather wilding or weirding. We're getting snowfall in deserts where that never happened before. You name it, we're getting it.
I like that term, weather weirding, because it sounds like what it is. It's definitely weird and it's definitely wild. And we've spoken about Hurricane Katrina, and I do want to recommend a podcast that I've been listening to that is really helpful. It's got a beautiful narrative, and it speaks to all the failures that had helped lead this natural disaster into a true man-made disaster. This podcast is called Floodlines, and we'll put that in the description below. But, just think of it. We had people who left New Orleans to Houston, and then they were caught in Hurricane Harvey. And then, of course, we had the infrastructure failures after Sandy here in the Northeast. I mean, some of the subways were inaccessible for years, many, many years. So it's highly problematic. Peter?
Yeah, I'd really like to thank Paul for that brilliant, detailed explanation of Hurricane Harvey. That was really, really worth listening to. Extreme weather events, they don't just happen in isolation. The scientists have been telling us for many years that we can have regions that are affected first by a heat wave or a drought, and then almost immediately after, they can be flooded out. In Niger, I remember a few years ago, they had an awful, horrendous drought. But as soon as the drought started to lift, the land was flooded out. There was a massive flood almost at the same time. And this devastated, of course, the land. I want to talk about agriculture. The impacts of torrential rain and flooding on agriculture are as bad as the effects that we're all familiar with and we all think about of heat and drought. And this has happened in a disastrous way quite recently in the Western United States. When the land is flooded for a long period of time and waterlogged, it can be ruined for years and years and years. So we have been able to make a great success of agriculture over the last 10,000 years because we've had this rather unusual moderate climate and really not very many extreme weather events and not very often. So when they happen, we can get over them. But we have now, as Paul indicated, we've now entered a completely new age. And the climate and the oceans are already fundamentally different than they were when I was born and came into this wonderful, glorious planet Earth. But also just in the past 40, 50 years, things are totally, totally different. And, Paul and I and other people that follow the science around the planet, we try and keep up with this. And Paul makes these great videos, and I'm even trying to do Twitter and Facebook. They're overwhelming. They're overwhelming. These horrendous, horrifying scientific reports of documenting what's happening and where it's happening and how the speed is accelerating and how it's inevitably going to accelerate even further in the future. They're absolutely overwhelming. Just one final thing. Oh, and I remember, for example, 2010, Pakistan, right? Unprecedented floods. Remember those aerial photographs? It looked like the flooded land went on forever. 20 million people were displaced from Pakistan. And certainly I'm aware that several years after those floods, the people were still suffering from an inability to grow their crops as they usually can because of the effect of the flooding on the lands. Hopefully they've got over it by now, but it did last for years and years. Extreme weather events in the sense of superstorms, more severe hurricanes, more severe cyclones, more torrential rains, and more floods. This is predictable. This is predictable by the basic science, because when we add greenhouse gases to the lower atmosphere, it's not just heat, it's energy. It's energy. We are adding energy to the lower atmosphere. Now, Paul mentioned the data of how much water vapor increases with how much of a degree of temperature increase. I want to mention one research project, which was 3 years ago. It was a combination of scientists from the University of British Columbia and I think an American university, and they looked at what extreme weather events did to the crop productivity in various regions. And they found, of course, that there was a very sharp drop in the food productivity immediately after the extreme weather event. But guess what? The temperate regions, the supposedly less vulnerable regions to climate disruption, they were affected even worse than the tropical lower latitude regions. They suffered very sharp drops in food productivity. You know, they picked up again after the crops recovered. We're on a scenario in which agriculture is not going to work anymore. Governments that continue to subsidize the fossil fuel industry, and the so-called post-COVID recovery is the biggest single subsidy that the fossil fuel industry has ever been given. Fossil fuel industry was on its knees prior to COVID and got way worse in COVID. What did governments do? They announced this post-COVID economic recovery. Yeah, sure. But the vast majority of the money went to the fossil fuel industry. That is a massive one-time subsidy. Over the past few years, the International Energy Agency tells us that these subsidies from governments to the fossil fuel industry are actually increasing. This is worse than insane. This is worse than the crime of all time.
Thank you so much, Peter. Agreed, 100%. And thank you for bringing up the issue of Pakistan. And of course, I can't seem to let an episode go without mentioning the thing that is very troubling to me, which is people being forced from their homes due to massive climate events. And I just want to remind everyone that over 270 million people in 2020 were living in a country to which they migrated. And by the way, that number was a little under 170 million in 2000. So strap in and let's get ready, guys, because there's a lot of change afoot. We're going to have to be able to meet the challenges that are ahead. And thank you, Peter and Paul, for your insights on tonight's show. And thank you, everyone, for watching. Please, if you learned something from this video, and we hope you did, be sure to share, like, and certainly subscribe. Hit that bell so you can see our most recent uploads, because we want to make sure that you are ahead of the climate curve. Thank you again for joining in on another episode of the Climate Emergency Forum.